to mathematics. Let's discover today more solids. First of all, you need to remember the solids that we have studied: prisms, pyramids, cones, cylinders, spheres, and also platonic solids. But what about the shape of a soccer ball or football, like this one? As you can see, it has pentagons and hexagons as faces. So this is not a prism, not a pyramid or a sphere. Or this mineral called garnet. This is another polyhedron, but as you can see, the faces are hexagons and squares. So we need to introduce another kind of polyhedrons. These ones are called the Archimedean solids. The Archimedean solids are named after the ancient Greek mathematician Archimedes, who probably discovered them in the 3rd century before Christ. And it is thought to be by combining and truncating the Platonic solids that he discovered them. So the Archimedean solids are the only 13 polyhedra or polyhedrons that are convex, have identical vertices, and their faces are regular polygons, not equal, because then there will be Platonic solids. The names are a little difficult. As you can see, the first one, truncated tetrahedron, cuboctahedron, truncated octahedron, and so on. This image is from ResearchGate, and you can see it if you like. And here you have 3 of them. These are templates that I did the other day. These are from left to right: the truncated tetrahedron, the truncated cube, and the cuboctahedron. You can obtain these templates and more of them, like the Platonic solids or any other polyhedron, in this website, polyhedra.net. Let's see how to obtain 2 of them, the truncated tetrahedron and the truncated cube. So here you have a plasticine model of a tetrahedron. As you can see, the faces are triangles. Obviously not equilateral triangles, because I'm not really good at plasticine, but more or less you get the idea. So this is a tetrahedron for faces that are triangular, okay, equilateral triangles. Okay, and now here you have the Archimedean solid. This is the truncated tetrahedron. As you can see, it's something like the other one, but with pieces that are missing. Why is that? Because you need to get the tetrahedron and chop some of the vertex here. As you can see, you get more or less badly, but more or less you can see that when you chop this part, you get here the triangle, okay, that you were trying to get. If you do this 3 more times, chopping this part, this part, and this part, then you get the truncated tetrahedron. Take a look at this template, and you would see that all the edges, I don't know if you can see it better maybe here, all the edges are the same. So the trick is just divide in 3 parts this edge, okay, every edge in fact, and then chop the part that you don't want, and that's it. You get the truncated tetrahedron. The same thing goes for the truncated cube. Let's see, here you have a cube, okay, And here, there you go, you have the truncated cube. Again, it's very similar, but there are things missing here. Okay, why? Because the same as before, you need to chop, you need to get rid of some parts in your cube. Okay, and then you get the shape that you are looking for. The same as before, all the edges are the same side, all of them. Okay, so the thing is to divide these edges in 3 equal parts. Not as I did, because this is very bad, but I think that you can get the idea just looking at this cutting here. Okay, there are other Archimedean solids that you can get by truncating the platonic solid, but they are more difficult to do with plasticine. So I hope you understand that I have only 2. Okay, so that's it for today.